Okay, well, hello Fatima. Thanks, thanks for joining. Kevin may not join. Some he need. There are some urgent things to complete, but we will keep helping him. And you may have seen that he didn't. He did reasonably good on the seminar, or you may watch this recordings later. There are several things to improve, but for the in the given time limitations, it was not bad for the presentation. So today we will try to keep the momentum towards the new wave of papers, and we will try to focus on the results section. And at the end of the meeting, we will check if we want to go forward to the next section, which will be like the conclusions, or we may do a second session on the results, because the deadlines for most journals are postponed due to recent changes, and I think it is an option. I haven't heard from molecular physics, but it's typical. The notifications of postponed deadlines by like a week or two are very reasonable at this time. So there was just an email I did shared. I tried my best to share all materials as links to Google Drive and Google Docs. So you may try to download them or try to edit online. So I do not have strict preference. Maybe we can take liberty in everyone. Selecting a different form of providing feedback, but the forms are they're quite silly, and this is just a little guideline what to look for, and what to edit, what to correct in the results section. So it's good custom if results section refer to all figures, and if any of the figures are missed, or they are not in the subsequent order, the reviewer may mention it to the author. This year we are going through figures and results first, but one of the alternative direction of arranging efforts is to start with the conclusions. And since most of you have either presented in form orally or as a poster, it looks like each of us has a verbal explanation of the goal, and one may help, as a reviewers, we may help author to judge if the this and that paragraph in the paper is needed, if it helps to follow main goal. Another little thing that often happened to me in the past, and maybe it keeps happening in the present, and I do not exclude that I'm not the only one. Just by style of human thinking, there is a danger to write explanation, write result section just as a collection of independent sentences or independent paragraphs. So if you do see a way to help author to check that the parts of the result section are connected to each other in a logical way, it will be appreciated. So in also the next little part is an option, but one can try to help the author by reproducing the logics of the result section if you as you understand it. So maybe one of the quite simple arrangements is like geometrical structure. It's one of the possible sequences, but it doesn't mean that it is the best, because there are connections, structure to property relations, from structure to basic electronic structure to observables, and since this year most of the papers go out of box into new directions, like magnetic field, electric field, presence of new effects like polarons. The logic can be different, and if you see this logic or it seems to you as a reviewer that you see it, it could be helpful if you reproduce it and share with the author. Also, a useful suggestion from reviewers to authors, that for authors it is all sections and all sentences are too much near and dear to the heart, and it's hard to be critical to your own writing. And as reviewers may help author to identify if some parts can be swapped. Sometimes just swapping a couple of paragraphs makes reading substantially more understandable. And if you see that some part of the text is not needed, if it creates some information of very similar by its nature, one can suggest to remove it or just migrate it to the supporting information. In a very silly and simplified way, results section is just one by one explanation of what is shown in the figures. So it's, of course, we try to do better, but one can check through this three check boxes if the explanation of figures is available in the results section. There is a plan to add discussion section to all of our papers, but by looking through figures and results, reviewers may judge if authors focus attention of a reader on something really interesting, really important, because what we do is expected to impress first the researcher, the main author who is doing it, and second the readers and reviewers, and maybe some part of what we are doing can attract more attention. So if some of the characteristics take record values or act in the way opposite to expectations, it is worth of mentioning, and even if author doesn't recognize it, reviewers may help it. So the plan is that we will invest about maybe 50 minutes in reading materials. So I did try my best to share links. So please try to access it on the electronically, and I think printing and writing by hand is the best possible option, but it doesn't seem available right now. So I suggest that each of us tries some options, and maybe then we share with each other which one was more favorable, like going into Google Docs and type with red font comments between lines, or try to add comments or maybe handwriting in the Acrobat. So let's invest about 10-15 minutes per piece, and then we will try to discuss each section as we did before. So giving word to each of the reviewers and sharing findings and sharing criticism. So please let me know if you didn't get the materials, or you have no idea how to read and edit it. So if there are no objections, then let me invite everyone to open file and start reading and adding comments. And if there are something urgent to interrupt this activity, please do it through microphone, because some of us may decide to mute the microphone, but to attract attention, just put your microphone on and tell, like, I want to attract attention, something like that. Okay, then I'm going to focus on these materials one by one, and now it's 4:24. So maybe 5:15 we will approximately, or as everyone is, or most of us are ready, we will start discussing result sections. It looks like cat is assisting to edit. So how does reading and feedbacking is going? Um, am I the last, or someone else is yet reading and writing?
I'm still reading.
Um, how many pieces do you have left for reading?
About half of Kevin's, probably even less than half.
And
A paragraph of Kevin's.
okay.
As I scroll down.
Okay. And are you done with Fatima's?
I'm done with Fatima's and Aaron's.
Oh, okay.
And as far as Calculin just has figures in the files.
Okay. Okay. Yeah, please keep reading, and in like maybe we will start from Fatima in a couple of minutes. So I suggest we discuss and check who is volunteering to give comments, and the person who is giving comments can click the button in this Perovskite software for sharing screen, and then if there were um, any written comments, one can show them, share them, and point attention. So I want to say hi to Aaron, who is another assistant for editing. Who is?
It was very helpful.
Oh yes, absolutely. I saw yours was looking into screen with great curiosity.
He loves to sit on my laptop.
Mine likes to type, like walking on the laptop on all keys one after another, and then it is how the text are generated. So who wants to be who wants to share comments on Fatima's work? David, are you interested? Do you have many comments?
Most of my comments on Fatima's are fairly obvious that she's missing things, so I'm not entirely sure what the sentences are meant to say.
Okay. I think after this session,
which I just assume she's missing equations or something that she hasn't typed into it yet. But
we are making reverse engineering. We are doing figures and results, and equations will be added later.
Yeah, that's what I'm assuming is missing from her work here.
Okay, and I may forget it later, but I suggest after completing the meeting, all reviewers will share all feedback with all authors, or maybe just circulate to everyone, because inside the group it's not a big secret, because maybe some of the materials are already typed in and it will be easier to edit. Aaron, do you have anything on Fatima's work?
Um,
Like, do you have many?
Nothing else.
Huh?
I guess the only thing I put in was just the sequence and logical construction.
But do you suggest specific changes? Specific changes, or
The only thing I initially thought of was in the figures it mentions plotting eigenvalues with magnetic field, but it might be good to compare what the MATLAB or what the values are without the field too. So like no field and then a little bit higher.
oh, adding a reference point?
Mm-hmm.
Yeah, yeah, it's a good idea, and generally, it is so much possible to avalanche amount of information, and if anything is interesting but looks excessive for main paper, one can always add it to the supporting information.
Mm-hmm.
Yvonne, do you have to say anything about Fatima's work? If you don't, you do not just do not turn on the microphone. Okay, I consider it as no. Let me quickly share. Let me quickly share, and then we'll go to the next one. Uh, the laptop is experiencing a little bit of slow down because of this parallel tasking. Oh, it's Kevin. It's Kevin. Pardon me. Uh, few seconds more. Okay. So the beginning of the text, I understand that in the previous sections it will be a little guide line over these materials, and it will be clear why this and that part are presented. But a reader may need a reminder, like that this section helps to get input, subsection, get input parameters of the Hamiltonian. And later on, one may need to say that the dispersion is obtained by solving type binding equations, or this portion is not original research. It is borrowed from the literature for consistency, but still one may mention. And it is reasonable to give a disclaimer: where are the original results, where are the information from the literature. So if the next paragraph is about the analysis of the dispersion computed by time binding, one can mention it. So for the actual results, one may highlight that eigenstates are shown there are representative. At least we want to believe and to, how to say, to sell that eigenstates that are being shown are most typical. Here I'm asking some questions, but I'm not sure if I have the answers. But like, which eigenstates are selected? What was the criterion to select them? Also, since one is showing only few orbitals, and some people, some readers are not happy to watch figures. Some people like numbers. Is there a way to summarize, at least verbally or maybe with a table, what will be the quantitative feature of each eigenstate, like energy, but in addition maybe expectation value of momentum of x and y, maybe the angular momentum. So something in addition to the energy and just shape of the orbital. Even if we are not going to give this data, it's not a big secret, and a reviewer will likely ask about it anyway. And you may say that these orbitals are expected to have similar expectation values, or they expected to have drastically different. So next, there is a comparison, very brief, but it is good. Fatima provides comparison of two types of eigenstates as they distribute in momentum space. She is mentioning that there are two types. One is localized, another is delocalized. But it is very brief, and impatient reader may jump over it, and we may stop him or her and focus, give a summary statement, like, if we expect it, we may, if we see it, we may tell that all orbitals will fall into one of the categories: localized near Dirac or delocalized in a circular manner, if it is so. What is the number of states of each type? can we say that there are more localized, less delocalized? And here is the question that deals with previous suggestion about quantitative measure. Like if a state is neither localized and nor delocalized, what will be the way to quantitatively characterize it? Is there a measure of localization, delocalization in momentum space? Now, the energy offsets between energies of eigenstates, are they dense or sparse? This is not simple curiosity just for fun. It is important because offset between energies determines whether the material is metal, semiconductor, or dielectric. So if possible, add those would be great. If not, at least to address verbally how dense or sparse the states are. Then the author switches the gears and goes into dynamics. And a reader may be shocked for such quick transition, and one may need an introductory sentence that we need dynamics because we are looking for non-equilibrium phenomena. Maybe we are considering instantaneous excitation optically or instantaneous switching of magnetic field. Maybe some idea how the states were prepared. The sentence here provides really great analysis. There is a lot of potential in this sentence, but it can be expanded so that magnetic field promotes signatures of wave nature of this states that are of the similar nature as formation of Landau states. But one may say that the larger the magnetic field, the larger this extent of wavy nature. Expectation values for this non-equilibrium dynamics depend on time, but what do we learn from them? Maybe similar summary statements as for previous paragraph could be useful. I'm done with this one, and let me ask once again if anyone has more comments to Fatima's work. If no, let's go to Kevin. David, are you done with reading Kevin's comments?
Yeah.
Do you want to share screen and entertain us with some comments, like present what is good and what is not so good in Kevin's work?
How do I do that?
If you move the mouse across the window where all our faces are, on the bottom there are buttons, and there are pictograms like microphone, camera, telephone, screen, and PDF.
Okay.
So if you click on the screen, it will start sharing the screen. If you have multiple displays, it will ask which display you want to share, and then we all will see what you see on your screen, and then you can bring any document and
I see the PDF, but I don't see a screen.
Can you save your comments as PDF and share as PDF?
I should be able to. Just give me a second.
Okay.
Not the right one, though.
Yes, yes, we see it.
So it appears to be a bit small, as I'm looking at it at least. So my major issue with this is it took me a while to find a copy of this figure, so I had to find the figures to actually figure out what was being told to me.
Uh-huh.
So that's actually why it took me so long. In his paragraph on figure 4, I'm assuming figure 1 and 2 are going to be in the intro. He's going to talk about them, looking at their intro figures. He has some weird wording in his paragraph on figure 4. And I just assume it's a typo from what I'm reading, but and then on his paragraph on figure 5 and 6, I put all the comments kind of together, but he's talking about how they contradict with figure 3, and I'm just wondering where figure 3, where he actually determined the DOS in relation to the time steps that are shown in figure 5. And it's also the way he's wording it, I'm not entirely clear whether the issue is with time or with temperature.
You are not alone in this question. Yesterday, when Kevin was giving seminar in physics, it was majority of questions were about this issue. So you're asking very, very relevant thing. Okay.
He's then skipped figure 7 and 8 in his results.
Exactly. So one needs either to describe 7 and 8, or just if they are not needed, then renumber and call yes.
If I remember what they are he does need them there. Although I think figure 7 should probably be earlier in the paper than 7, because that's the orbitals, if I remember. So then I didn't actually type out the comments for it, but all his blue figures and green figures, I was questioning some of his explanations, specifically on the band gap, or not the band gap, the initial energies, why it's at the low temperatures they have a large gap. Well, at the high temperatures they have a minimal gap, and looking at the figures I found, the relaxation time seems to be pretty much in the same general area once you get past the 500K point. And he talks about how it becomes where was it? He talks about how it becomes increasingly smaller with higher temperatures, and looking at it just by eye, it looks like past the 500K point there, basically identical. He may want to add a table or something to add if he's going to claim this, so we can actually see numbers for it. That was my major comments for his.
Okay, yeah, thank you. Anyone else wants to comment on Kevin's? If no, I will quickly give, or maybe not quickly, give my comments, and then we'll go to Yvonne and then to Aaron. So Kevin is talking about HOMO and LUMO, but in his figures on orbitals, I think he shows only HOMO and not LUMO or otherwise. It would be just reasonable to add. Discussion about superpositions is cool, but it is maybe more appropriate for the discussion section. I'm just aware of Kevin's very recent results, and since we discussed his results together, he computed density of states and absorption spectrum for undoped model, and in this discussion it should be also reflected. So comparison of spectrum of doped and undoped. He is correct mentioning that lowest transition in the doped model is dark, but it would be correct and very more attractive to read if he contrasts this observation with telling what about lowest transition in the undoped model, and it is expected to be bright. Then Kevin tries to provide a discussion why the lowest transition in the doped model is dark, but there are some suggestions to focus on the spatial localization of the involved orbitals, and if they are localized in different areas of space, if there is no overlap of initial and final orbital, then any transition will be very inefficient. So this charge transfer character of the lowest transition in the doped model is responsible for it being optically dark. And Kevin may consider to add discussion or interpretation like this. Then he's jumping from ground state electronic structure to dynamics, to the fluctuations. And all is good, but again, the transition is too quick. One may calm the reader and explain how this transition is going. And it is what David was asking, and it was asked to Kevin on his seminar. He may highlight again or recall it for readers that there was a stage of heating and stage of molecular dynamics, and because heating was short enough, first steps of molecular dynamics represent non-equilibrium situation, and the fluctuation that he is showing and describing are this dynamics of transition from non-equilibrium when all energy is kinetic energy to equilibrium when it is equally distributed between kinetic and potential energy. This sentence would clarify the issues after that, because this closure of the gap is evident with the signature of this non-equilibrium molecular dynamics. At a later stage, Kevin may decide to seed through his results section and parse several fragments and move them, migrate them from results to discussion. Right now, he is mixing results and discussion, which is not bad, but it's common practice to chop and separate. First, just present facts and then make a separate section with interpretation and discussion. So he, in his discussion here about the closure of the gap and height of the skyscrapers, the intensity of red field non-equilibrium non-radiative transitions, it looks like he's mixing two effects into one bundle, and those are two different effects. David was absolutely correct by recognizing it. So there is a dependence on time and dependence on temperature. Dependence on time would go away if one would use longer time period for equilibration, for thermal equilibration, for heating the model. The dependence on temperature will stay anyway, and Kevin may benefit from discussing these two effects separately. So it is really cool. Stop. It's really cool to observe closing of the gap in a real time, but in some sense it is an artifact of the quick heating. If one and one needs to recognize it and comment on that. So this is not a primary effect. It's a cool observation, but it is not major thing, and it will not stay if one try to reproduce this numerical experiment with longer thermostat contact. Again, I'm echoing comment of David that a couple of figures are missed. And let me see if there were more comments. We will discuss this aspect in looking at new figures by Yulun, but Kevin is writing the magnitude of the charge transfer increases with temperature. This is a good observation, but it is a little unspecific. So one may want to make an intellectual effort to define this term of the magnitude of charge transfer and maybe give units or be more quantitative about it. So it is about blue figures. Okay, I think I'm done. Yes, I'm done with this part, with Kevin's part. Fatima? I will ask you to give comments on Aaron's paper next. So you may prepare your thoughts. And let me ask Aaron to give comments on Yulun's work, if any.
The only question I had was, I noticed it looked like in the table of the observables, it looked like he added a charge transfer rate for all the various electric fields that he computed the dynamics for. I was just wondering, did he fit the blue figure? Did he fit that to a curve, or just extract it manually? Or assuming that's where you got the charge transfer rate from.
Yuan,
So I guess can you hear me?
yes, I think everyone except Yuan should mute the microphone so that feedback doesn't develop. Yuan, can you please answer the question by Aaron? We were hearing you, but then the voice disappeared. Or maybe you can type in the chat room if so I will try to address, but I do not have guarantee because I haven't seen the results. I can only provide interpretation. Even if you switch the microphone on, please speak yourself or correct me. It looks like there is a measure of charge transfer, such as electric dipole across the system, and this electric dipole can be fit into mono-exponential curve in the same way as we process the energy. Does it sound reasonable for Aaron?
Mm-hmm. Yeah, that makes sense.
Okay. David, do you have comments on Yuan's work?
All my comment was on basically the same thing.
Okay.
So I think that answer was good enough for me.
Okay, good. I am going to quickly run through these figures and check. Maybe I've made a couple of additional comments. My laptop is extremely delayed and it does something with like 5-10 seconds delay after I click. It's does things later. Okay. It's a matter of taste, but I would present model first and electronic structure second. For electronic structure, maybe I know that it more belongs to results, but I would add it right in the caption, like negative field pushes conduction and valence band away from each other, or positive pushes them close to each other. And a reviewer would definitely ask if the equilibrium geometry changes under the field. And if we know that there are software glitch that prevents us from this, we may either comment on this or tell that we intentionally neglect it because we focus only on electronic features. But it will be a very natural question of the reviewer. For the next figure, which is really, really cool. Also, it's a matter of personal taste, but one may add the main observation right in the figure caption, that positive field closes valence and conduction band close to each other, closing the gap. And when gap closes, system becomes metallic and conductivity increases exponentially, like increases by like orders of magnitude. And it is really interesting result. If this project would become a major focus, it would be really great to see if the same result can be reproduced by changing ab initio data with dipole approximation for energy of each orbital changed as function of electric field. So for the panel A in figure 3, there is a little feature in the whole relaxation with quasi-stationary state, and there is just a little curiosity, what is the state, why Hall wants to park there for certain time. Maybe it's excited Hall on the die, and then it takes additional like 10 picosecond to relax to the lowest state on the die. For the panel B, one may address visually by text, by equations, maybe in several places, that the offset between solid and dashed lines is distance between positive and negative charge. Distance between positive and negative charge is a definition of dipole. And in some sense, it is a very, it's a very good quantitative measure for the efficiency of charge transfer. We may say that charge transfer, like one elementary charge transfers, travels by the distance of 20 angstrom. And as time passes by, this dipole increases. The value of the dipole in the plane capacitor corresponds to intrinsic electric field that may fight back against the external electric field. And then it, we are not including this effect, but it may shorten the overall electric field acting on the system. So it opens box for more deeper analysis and for some interesting nonlinear effects. But it is it will be different. It will be attracting attention, positive attention of reviewers. It's interesting effects. For the table. I do not know if it is possible, but this data of whole cooling, electron cooling and charge transfer rates, I wonder if this data can be represented graphically, if there will be some interesting trends. I don't know. Okay, I'm done with Yvonne's paper, and let's check if Fatima has feedback to Aaron's paper. You probably have your microphone is off. Can you unmute the microphone?
Now it is okay.
Oh yes, thank you.
So I have very few comments on Aaron's results. As I can see, he didn't write anything about figure 1. I understand that he will write about the atomistic model on computational details.
Your call will be disconnected.
Do not worry, we are still on the connection.
So this figure 1a.
No, we are disconnected. Okay.